Okie dokie. Right, day three, except that briefly I'm going to move my computer into a new module. I guess intcomp.rs will do. So we're going to take basically all of day two. Run program, run instruction. We don't need part two and part one, so we want run program. I'll take all the tests for now. It's going to be some imports that we don't have. As a program string, that's still going to be fine. So let's get rid of all of those. And we will modern comp. In fact, okay, let's use great int comp. And I need to mod int comp up here. What are you unhappy about? Part one, that test can disappear. And you're not used, so it's just going to be int comp. Take those, these are not public functions, so it's going to be unhappy. Okay, and you need to be pub. You don't for now. You don't need to be pub. You need to be pub. Happy? No. Because of tests. So most of these tests can go. In fact, all of these tests can go. Okay. Tests run. There were 5. But okay, that's fine. And everything still works. Perfect. Let's add those. No, 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 don't do that. In fact, can I just... Yeah. Great, okay. So, day 3. Public functions that I have exported in here are... Can I... Oh, no. Parse string and run program. I guess parse string didn't actually need to be... yeah, because I have to change bits of it. Okay. Okay, day 3. This is only going to be a short stream, so I might not finish day 3 today. Gravity test successful, great. Front panel general wires, 2 wires connect to central port. Trace the path each wire takes central port, 1 wire. Oh. Okay, Manhattan distance means no hypotenuses, I think. Yeah. first wire's path is right 8, up 5, left 5, starting from the central port there. Okay. Oof. These wires cross at 2 locations, but the lower left one is closer to the central port. Its distance is... Oh, okay. So, before I've seen part 2, I assume... Well, first off, this is not an encode problem, so that's nice. The simple way of doing this is going to be to use a hash set. Well, use any set. I think there's a B tree set as well, but hash set would be fastest, and you can do the difference method between another hash set, which I assume means it's got a similar method. Yeah, okay, so you could do a union of 2 hash sets, which means you need to trace out the entire path. Do we know where the origin is? Is it just... it always starts from some fixed point? So I'd need a hash set of tuples representing xy coordinates, I think. Okay, what's the puzzle input look like? Well, so if I have these 2, let's assume each input is going to be a line. No, those were 2 individual things. Okay, so we'll just take that for a moment. In fact, you know what, screw it, we don't need a Day3 test. Let's just go grab the parcel input. Okay, so we have 2 lines that are going to be doing a thing. So let's make our test module, and yeah, we'll do that. Function. So we're going to test yeah, let's briefly test create hash set. Take nothing. So we're going to say const test input equal test input is a register, and it's not going to be that. Let's just go and take this first one. I don't want to do this first one for the whole thing though. Line 1. Was that faster? Most definitely not. It's going 75 rate. I'm not going to type this hash out by hand. So let's say const test hash input. It's going to be register, and it's going to be right 2, down 3, up 2, left 1. And I don't think I can create a hash set like that. So we need to standard collections hash set. And a hash set is just going to be a thing of everything. Hash set new. Is there a hash set from? Capacity zero capacity. Insert intersection. What's the intersection and union? Right, okay. We have from. Yeah. So you could do hash set from an array. In which case I can do this. Test cohorts is going to be an array of tuples of isizers. Isize. And we're going to start at the origin. So the origin exists. Maybe the origin shouldn't exist because that's just going to make life a bit easier taking it out. And we're going to go right to, so we're going to go 1, so let's say right is positive. Right is positive and up is positive. That's the definition we're going to make. So we're going to go 1, 0, 2, 0, and then we're going to go down 2 to minus 1, 2 minus 2, 2 minus 3. I probably should have checked to see if those were 1 minus 3 is correct. No, because we're going up to 1 minus 3 is not correct. 2 minus 2. I didn't think about that very well, did I? Should go left once first. In which case it's going to be 1 minus 3. And then it's going to be 1 minus 2 and 1 minus 1. Is it going to complain and tell me this is a size? So from test coords that expect. Create set on test hash input. Assert equals chords expect. Cool. Day 3. Cool, that's better. Can't compile because no function called create set. And we need a size name compiler. One, two, three, four, five, six, seven, 8. Okay. It's going to take an input, which is str. It's going to return a hash set by size, nice size. And for now, that is a to-do. Test should run and fail. Okay, cool. Now the input is going to be in the form of this. Create a new hash set. And input split on comma. map, and then we're going to have, I really don't want to use a regex for this, we're going to have a letter and a number, and the number may have digits, more than 3 digits. Oh, it's going to give me an iterator of chars. No, okay, right, I see. It's going to give me an S, and the S is a ref str, and I want to take yeah, no, that won't work because next we'll actually take the thing, but otherwise it might, and X and Y need to be in a different place. So yeah, let me start 0, 0. And we're going to return set. So s dot chars next on that. Does that consume it? Turns an iterator, and it just takes a reference. Oh, okay, so it does still exist. So actually, that probably is going to work. Are you allowed to do that? Yeah, match dir. So it's going to be R. If we're going right, then our x coordinates. Okay, I want to generate all coordinates for this. Go away for a moment. 0 up to and including dist. Add 1 and insert to set.insert start. Yeah, that is probably correct. So let's do left next. So yeah, that looks about right. And then up. If up happens, then start.1 is going to be increased. Yeah. Down, then start.1 is going to be decreased, and we'll insert that into the set. That's fine. And we need a. So everything else is an underscore, and it's going to be panic. Invalid direction. Okay, iterator is lazy, so I would need to assign. So if we do nothing with this iterator, it just won't do anything with it. So we need to actually say we're going to do something with it, but then secretly throw the result away. You go away. Right, so matching is the same as it is in any language. There are whole fancy match guards, but we don't need to worry about those for now. Tab9 wrote the line above, and I don't know if this is actually going to work, but that's what we've got tests for. See what happens. See, look, up, right, cool. Why? What did you get wrong? Left, 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 left. Left is coords, which comes from create sets. On test hash input, it did nothing. Why did it do nothing? It did not panic. Well, tell you what, the easiest way to do this, it's possible it's actually not evaluating. Set.insert 0, 0. Oh. Yeah, insert returns whether or not it was already found. Still not happy? What don't you like? Oh, yeah. Of course. So, do we have any zeros? We don't. Okay, right, this entire iterator isn't happening. So, instead, we'll do for underscore in. Expected a block. Yes, for underscore for S. For S in inputs. Let's do a lot. We no longer need any of that. And now I've got a bracket problem down there. Right, okay. So let's make this panic again. We start out with 2, 0. They're not going to be equal. We've got way too many values in this set anyway. So we start out at 2, 0. We go to... We start at 0, 0. We go to 1, 0. We go to 2, 0. Why do we have extras? Let's see if we can work it out. 1, 0, 2, 0. It looks like we went to 3, 0. Are we going one extra in each direction, isn't it? Because, yeah, it is. I thought I was adding on dist. I was not. I just needed to do it that many times. Tests. Right, test passed. Sweet. So, create set is going to create a set from the thing. Hop on run is going to return. I may as well do iSize. It's going to make life slightly easier. Let's path be equal to path new base dir join real day 3. Yep. Also, yep. Okay. I, for now, think that everything can be done in here, yeah. So, I know the dataset only has 2 lines, so I'm gonna say data lines. Lines. Let's set A. Let's set A equal create set lines next unwrap, and let's set B, and then we do the same. So lines.next unwrap is going to take the next value. Well, lines.next is going to take the next value, so lines will then point to the next item. So we just do exactly the same. Could probably expect those to work out where it's panicking, but we'll be told anyway. Now we need to find the intersections. Is Is it intersection or is it union? Intersection visits the values in both. That actually might. Why is that different? Without duplicates. Right, sorry, yeah. Union is every single one of them. Intersection is exactly what I want. So this would give you 2 and 3 only. Yeah, okay. And the distance actually is super easy. Intersection. In fact, I don't even need to do that. I just need to do set A intersection with set B. Mu min is equal to 0. In fact, let's do I size max. For points in that. Yep. Yep. And then we'll return min. So I can go and test this. Test part 1. So we are going to. Oh, okay. If I want to test this, I'm actually going to have to do find this, and it's going to have set A is a hash set of size and set B. Pretty sure these are supposed to be underscores. Yeah, it should. Oh, was it Control F2? Set A, and we'll do lowercase. Okay. What don't you like about that? Borrowing. Okay, that's fine. Is a hash set of ice size and ice size. It's going to return an ice size. We don't need that line anymore. You can go up. These two. So go up. That works. And that works. So now I can do find min distance. Great. So I know test create set works. So let's set A equal test. I know create set works. Create set on test input line 1. Let's set B on line 2. Let result equal find min distance A and B, and let expect equal 159. Definitely there's some code floating around that's already doing this. Okay, compile problem up here because, yeah, we're not returning 0. That one, and use standard path. Cool. One test part. I didn't annotate it as test. That's why. Two passed. Great. What could go wrong? It doesn't really. Yeah, fuck it. Day 3. In fact, where's that for? Great. Day 3. Right. Yep. That's why. No test will stop you being an idiot. Now we're going to discover that that's mega slow. Okay, calculate the number of steps each one. Actually, I might be okay. I might have got away with this. Calculate the number of steps each Y takes to reach each intersection. That's easy enough. Choose the intersection where the sum of both Y's steps is lowest. Okay. So instead of creating a hash set, I just need a map, and the value in the map is basically going to be a counter counting upwards. What do I need to change? Find min distance is basically going to stay the same. Yeah, okay. I mean, it's annoying, but fine. So hash map is basically the same as the hash set, only with a value. And again, there are faster methods, but for now this will work fine. So we're actually going to have a map where our keys are our tuple of I sizes, and then whenever you size, just to make life a bit easier. No, because I'm returning I sizes. Do everything with I size. Mute dist is 0. And for each one, for each step we take, we're going to go dist plus equals 1, set.insert. Why you hash that right? Hash map. Insert takes 2 arguments. What happens if you've already been there? I don't know. Oh, okay. We've got. Yeah, I'm an idiot. That could have nearly gone quite horribly wrong. Okay, so now if I take this and go down here, test create map, expect is going to be a right. First off, let's create a map from that input, and let expect equal hash map new. I'm going to have to write this all out manually, aren't I? I guess it's not. I think you can create a map from tuples actually. values, don't care about that, then move reserve. From an iterator, yes. Okay, sweet. So I just need an iterator of key value pairs. Does fold does not produce an iterator. Okay. Just for the avoidance of doubt, test coords map. Here's an array of tuples like that. And that's one step. That is 2 steps. Be sure this is exactly the kind of thing I should be using AI for. Seven. Okay. Now I want to do a hash map from. Ooh. I can just do straight from array. Sweet. Hash map from, what did I call it? Test coords maps. Okay. New. 2 plus 1 failed. Great. What failed? Test create map. Failed. 1, 0 is 1 on the left. What's left? Left is what we actually got, which is correct. 2, 0, also 1. Yeah, okay, that's because I'm changing steps here. And actually, I want to do it there. That's why tests are good. Test pass. Okay. Right, so my create map works, and find min, what do they call it? Signal delay. Find min delay. Set A is not, so map A is a hash map. So, that is a good point actually. It's worth noting that this is consuming our data. This is taking a set. And that would be a problem. Normally, that would be something I want to avoid, except that I need to create different data structures for part 1 and part 2 anyway. I probably could actually do this. Ooh, yeah, I could, because I think the keys... can you build a set off of an iterator? Where's from? From iterator. You can. It would be more efficient, actually, to get rid of all of create set. Where are you? You are there. We're going to get rid of all that. We're going to that map is create new. We are going to change input to a map. I'm missing a bracket there. And we're going to get and what we're going to do is we're going to return hash map into keys. That's not the right method. Into underscore keys. going to do a hash set from iterator. In capitals. And the iterator is going to be our input into keys. And you're unhappy because find min delay is not doing anything. Is it just that? It's lowercase from underscore iter. It is a hash map of I size. There we go. We've still got problems up here. Yes, because part 1 is now going to do weird things. So I'm going to pass in set A, which is a hash map of I size, and set B, which is the same. And at this point, it might have been more convenient to do an alias. And those are actually going to be references to hash maps, which hopefully I will be fine. You're going to go up into run. And then we're going to create the map. Yeah, okay. I think it's about 45 minutes. Map. Part 1 is going to take ref set A and ref set B. You are going to be create set from is already references. Why are you unhappy? Right, yeah, because create map, create set needs to take a reference to a map. Really? Int keys. I just want keys instead of int keys. Expect a hash set and got a hash set of. That is fine. I don't need to do anything with those. Find min distance is going to take hash sets of references. And then my tests are all broken because test part 1 need to create maps first. So test create map already done. So let map A equal create map. In fact, okay, I've done it now. Map B, that one. And you are going to take map A. You're going to take map B. Test create set. We're going to let map create map from use test hash input. Yeah. Create set from ref map. I can't put a ref in front of all of these. So you can't have a pointer to something not allocated. So it needs to be allocated and exist and be owned somewhere. And I don't really want to go and box them all. I mean, just for the test. This feels like a really, really bad thing to do. Yeah, I would quite like to know this works, though. Okay. For code in expect, I think I can just do that. Assert that coords.contains, and it's going to be ref coord. Okay. Everything works. Test part 1, test create map. So all I need to do, let's just check that 248 was correct. So are these the same inputs as before? 75, 30, 83. Yeah, they are. So this is going to have 610 steps. So let's go test part 2. Let expect. And then I want to take those two. And then I want that assert equals. I should also go through and make these the right way around. That way. Okay, right, where's part 2? Oh, no, not part 2. Find min delay is a to-do. Okie dokie. And to do find min delay, what I'm actually going to have to do is these don't need to be consumed. So that's an iterator, and I probably, in fact, for intersect for intersection in. Okay, let min equal size max. Now the delay is the sum of the number of steps. So what I want to do, delay be equal to map a get, and get will return. I mean, I immediately know that it's there because I've done the intersection, and it's going to give me the value. Hash set new sum a. Yeah, okay. Dot get intersection. Get takes a reference to a key. K is ref q. Okay, I think that should be fine. Plus map b get intersection unwrap. If delay is less than min, then do that and return min. Test pass. So far, so good. Probably some duplication in min delay and min distance that I could get rid of as well, but oh well. So part 2 is going to take in set A and set no, it's going to take in map A and map B and return an size. I already created the maps in Run. Right. These are badly named. So part 1 is creating sets. Yeah, okay, cool. So all I need to do is find min delay. Map A, type is already correct. Not set B. Map B and return the value. Was the fewest combined steps. That feels like a long way, but it's correct. Nice. That was really blasting through and introduced some of the sets you can have, well, some of the types we can have, hash sets and hash maps. I really like hash sets. They're super useful. And it just winds me up that Go doesn't use them and you have to just make a map with true in it or something as the value. Why? What's the point? There are loads of others we could have used as well. Feature map, which can be can be faster, and I believe there is a B-tree set. Yeah, there's also a B-tree set. And I'm sure there are a bunch of others as well. Nice. Right, well, that's day 3 done.